Yeah, I see it.
All right, awesome. Thanks, Ari.
All right. Okay, yeah, so let's go over the agenda. Like I said, first we'll talk about the Hyperloop design manufacturing team, what we do. And then I'll be touching up on 4 different subjects. The first being CONOPS, which is a concept of operations, SolidWorks, CNC machining, and then 3D printing, and how we kind of integrate all those concepts into our design team, manufacturing team, and how generally it's integrated into the workforce and into like a professional atmosphere. So a brief overview. If you don't know already, the CPP Hyperloop design manufacturing team basically works on creating the actual functional Hyperloop pod. That's basically our goal for this semester. Basically, design and manufacturing are 2 different teams, both with around 4 to 5 members. And it's the design team who basically brainstorms the new ideas on how to build the pod, how it's going to work, how the braking system is going to work, how many wheels it's going to have, how we're going to station it onto the I-beam track. And that's their responsibility. And after brainstorming some ideas, they come up with some initial designs using SolidWorks. And I'll show you some pictures of designs that they've come up with this semester. And those designs basically kind of create the foundations for our Hyperloop pod. And alongside that, they do some theoretical calculation work just so that they can understand how much, how big of a surface area we might need for the braking system, clams, how much pressure we might need. And there's a bit of mathematical computational work that goes along with designing, and that's all the stuff that design team works on. And if you see on the picture, this is a Hyperloop pod. It's not our Hyperloop pod, but this is what a Hyperloop pod would look like for a competition. So this is something that we want to build by the end of next semester, and for this semester we want to at least have a subscale model of that around 1 foot to test and to see if it works. And the manufacturing team, basically based off of the designs that the design team creates, we do the 3D printing work. We put the pieces together to construct the pod once all the parts have been 3D printed or bought if we're going to buy them off the shelves. And also this semester, the manufacturing team is in charge of creating the I-beam. And part of that is to create professional 2D drawings of the I-beam track and, with details on how we're going to be attaching it together and sending over professional 2D drawings, detailed 2D drawings over to a manufacturing company so they can have it manufactured for us. For this semester, the ME technicians who help out with the labs in the ME department are helping us as well to make the I-beams. So basically, the manufacturing team works really close with the ME department to have the I-beam manufactured. And it's going to be made out of aluminum, so that's going to be cool. We're going to have a 50-foot track of aluminum I-beam connections, which we're going to use to test the pod on. So ultimately, that's what the design team and the manufacturing team works on. Okay, now let's go over some of the skills that we use in the design and manufacturing team. So Yash is in here, who is the design lead, but I'll be covering for him and kind of going over some of the things that they use in their kind of sub-team meetings. So the first is CONOPS. CONOPS basically stands for the concept of operations. And concept of operations is basically a detailed document of how a product will function when it's, fully ready for market and it's available for end users to use and operate. So, if this was a product that we were making and going to market, maybe like an iPhone or something like that, then this concept of operations would be basically a detailed description of how the iPhone works, what apps it's going to have, and how people will be able to use it and interact with it. So there's three main components, and you can abbreviate them with the PCO acronym. So first is detailing what the purpose of the product is, why we're building it in the first place, the characteristics, what parts should we include to meet a certain end goal or to meet a certain function, and then the operation is how will the customer or end user be able to operate to get that function. So if we have something like a Hyperloop pod, then our purpose would basically be to for a Hyperloop pod to be able to move maybe 50 50 feet a second or something like that at a certain speed across a straight aluminum I-beam. That is the purpose, and it's a general purpose. What characteristics is going to have? Well, we'll need a braking system, we'll need motors, we'll need a shell to house all the electrical components. So those will be the characteristics, and then the operation is, okay, we aren't going to be selling anything, but if this was going to be used by someone else who didn't work on the Hyperloop pod, then how would they operate? So is it by a switch of a button? Do they have to monitor things as they go, or is it automatic? Is there a button for the brakes, or are the brakes automatic based off of a timer? So those are the things that we have to keep in mind. And here's a pretty good example of a concept of operations. I believe it's by NASA. So ultimately, this basically kind of shows the process of how one of their products would work. So this looks like a space shuttle, and basically it kind of gives you a general idea of how it's going to work. So we have the pre-launch stage, and there's a power descent, and then there will be a separation stage, and then once it basically gets onto Moon or Mars or wherever it's going, then ultimately we see these kind of parachutes coming out, and slowly it descending onto the surface of Mars or Moon or the Moon or wherever it's going. And it gives a little bit of descriptions of what's actually going on. Right, so it's talking like reorientation, drogue deployed at what second, how many seconds, and stuff like that. So ultimately, it gives a pretty good detailed description of how exactly it's going to play out when we actually use the product. And that's something that we should also be doing when we're making anything, I guess, not just a pod, so people know exactly how our product is going to work once we finish it. So that's something that the design team would work on. And then also, of course, they work on SolidWorks. And I don't know if you know this, if you guys are ME students, or if you're engineering students, I'm pretty sure you all know this, but if you go to this link, this is the CPP Student Software Portal, and you can download SolidWorks, AutoCAD, Tinkercad, I think Fusion 360 as well, for free, and you can try those software services out. It's pretty cool. It's something that you can learn on your own, and as you get more practice, you can get better and better. So this is something that you should definitely check out if you don't have SolidWorks or another 3D modeling software already downloaded on your computer. But these are the designs that we came up with, or the design team came up with for the semester. So this is our 1 foot subscale model of the pod. We have a shell, we have braking systems. I don't know, it's a little bit hard to see, but there are solenoids in the front and in the back, which kind of maneuver the brake pads. We have motors. We have 4 motors actually, 2 in the back, 2 in the front. We have wheels attached to the web of the I-beam, on top of the I-beam. So yeah, so this is the design that the design team came up with. This is another view of the design. And these are the 2D drawings that my team came up with, the manufacturing team. So this is the 2D drawing of the I-beam that we sent out to the ME technicians to have it manufactured. So you can see that this is a pretty detailed drawing of how it's going to work out. This is one I-beam piece around around 14 inches in length, and it basically shows how we're going to connect it. So there are these connection pieces here that we're going to attach, and we're going to have little tap screws that we're going to put through, and some nuts and bolts. And basically, this is a typical drawing that not just in Hyperloop, but anywhere in industry you would have. Kind of like if you needed to get something manufactured, then you want to be as detailed as possible and send a drawing like this over so they can get the appropriate dimensions and send you the appropriate piece for your project. So these are the things that we've been doing pertaining to SolidWorks. Okay, and then we'll talk about a little bit about machining and 3D printing. So CNC machining basically stands for computer numerical control. It's ultimately a type of subtractive manufacturing process in which you basically have a metal bar of metal or basically a kind of like a metal plate, and it basically drills and cuts and shapes those metal bases, kind of like you see in this image, how it's basically kind of engraving CNC into this metal plate. So that's basically what a subtractive manufacturing is. It's removing parts from a block of metal to create a desired kind of piece of material. So it operates on G codes. It's pretty similar to 3D printing if you have a little bit of familiarity with that. Basically, the G codes kind of are used to program the CNC machines to basically have it make the exact kind of cuts and the exact drills and stuff like that. So because it's an automatic machine, so it uses G codes. And also 3D printing, I'm pretty sure you've heard about this from Alex or Chris. It's basically a process where you basically print out objects made of plastic, preferably PLA. You can also do ABS, which is a different type of plastic, but PLA is generally more safer to use. But yeah, so 3D printing, this how it works is you have a SolidWorks design, and after you get that design completed, you turn it into an STL file, use a slicing software that is basically something that the company from which you bought the 3D printer will provide you. So once you have a design on SolidWorks, you basically enter it into the slicing software. And once you slice it, it basically kind of creates the G code for the 3D printer to run. And you save it onto USB, onto an SD card. And basically, that's what you use for the 3D printer. And that's what the 3D printer will use to actually make the parts. So this is something that we're making. This is like part of the chassis for our pod. And this is what I'm going to be making tomorrow on my 3D printer. It takes around 17 hours to just print this much, but it's pretty slow. But yeah, once we have this finished, we're going to be kind of getting all the parts together and making the pod. So hopefully by next week, we'll have the entire pod completed and ready to test. But yeah, so basically this workshop was to introduce you to briefly introduce you to some of the topics that we kind of use in our design and manufacturing teams, and also talk a little bit more about what the design and manufacturing team does in CPP Hyperloop. So do you have any questions in regards to any of the things that I talked about? Okay, yeah, so basically it was a pretty short workshop. If you guys have any questions, or if you guys might be interested in maybe learning more about like the design process or the manufacturing process, or you might be interested in maybe trying out and being a member of the design and manufacturing team, if that's something that you might want to do next semester, then let us know. You have our contact information. And if you would like to join one of those teams just to try out something new, you can always do that. So thank you. I'll stop sharing. Recording.